Professor of Algorithms. Could be a good nickname. Hello, world. We are live. And this is LeetCode on a Fluke. Almost random, but we picked this problem, not too random. This problem is from the top interview 150 list at LeetCode. And it's in the topic about graphs. And let's see what we can do here. Surrounded regions. You're given a matrix, but M by N, containing, but it's not necessarily square. Could be of different. It's height and number of rows and columns could be different. So it containing letters X and O. Okay, so these are letters. Byte, type byte. Capture regions that are surrounded. Okay, connect. A cell is connected to adjacent cells horizontally. A cell is connected horizontally or vertically. Okay, region. To form a region, connect every zero. To form a region, the region is surrounded with X cells. If you can connect the region with X cells and none, the region cells are on the edge of the board. A surrounded region is captured by replacing O's with X's in the input matrix. Okay, so we changed the input matrix. We don't need to return anything. So we have this input, and the output will be that because the bottom region is not captured because it is on the edge of the board and cannot be surrounded. So the only problem, it seems so, first thing that caught my attention is that, if none of the parts of region are on the edge of the board, then it should be surrounded. Then it should be they call it captured. So that means they are surrounded. But overall, so we have these regions, and for this region to be, we could just go and change all the O's to the X's. By the way, this is ladder. This is not a zero. If it was a 0, it would look like that. O looks like that. And the difference is this. The difference is this. I don't know why it's not zooming in, but yeah, this little line crossing that. So these are O's. Key detail. Not really, but so how many viewers do we have? We have good 0 number of viewers. Okay, let's see what we can make here, what we can have here, make it here happen before we get more views, before we get more viewers. If we see, if we see a region, so whenever we will see 1 O, we need to make sure, I mean, to know that we can capture it. We need to know that it's not part of a region that's on the edge, right? Yeah, because there could be a no here, then we wouldn't be able to capture this entire region. So we cannot know that until we identify this. This region and know that and check if and check whether it has whether it has at least one part that's on the board, one piece that's on the edge. I'm thinking also for ways to look at it in it's a different standpoint. So another way to do would be, okay, we find a no. Then we can go around that region, and traverse that region. And check that. Yeah, check that all of its parts are surrounded by either axis, or there is just an O near adjacent to it. So until we do that and check the entire thing, so yeah, that's step 1. Is it surrounded? And if it is, then we can go ahead and flip it, capture it. Sounds like that. And that's for every region. So yeah, every region we need to first identify all its pieces. I mean, that by doing some type of traversal. And along doing that, we'll check that it's surrounded. So that's first. If it's surrounded, then we'll go around it again and traverse it again and flip it. So for every position in the matrix, we're gonna do that. Yeah, we're gonna see if it's we'll go around the matrix and yeah, at some point we'll hit that. Then we'll go around. Okay, we'll check it's surrounded, and we'll go and capture it. So we will need some kind of traversal of that region. That could be that could be what would be a good traversal. I mean, so far this seems pretty intuitive, because I mean the you see the just basic iteration over the matrix doesn't solve it, because when you iterate, you don't know what the region is, or the full geography of this region, whether it's surrounded or not, you don't know. So you just the computer will just open that box and so like, okay, I have a no, yeah, but that's all I know now. That I have one no. I might know yet if this O is surrounded or not, but that's all. But if there is more than one O, if there is an adjacent O, yeah, we don't know. We see that, but we will need to check that and all the adjacent ones. And let's see, what should we use for that traversal? Could we use depth first search here? Depth. Like we find that node, then we'll check its adjacent nodes to look for another O. And so yeah, we'll loop over the adjacency list of that node. But we need to track visited as we go around that region. So because this node will have that as if in its adjacency list. We need to skip that. So that's for depth first search. Okay, if we do breadth first search, we'll find that node. We'll queue up all of its adjacency values. these values, we'll go over them and queue up all of theirs, and that, yeah, then it again will include the previous ones. So I think depth first search should do it. Yeah, given we track the visited, and we'll just go until, yeah, recursively in each node, we'll look at its neighbors, non-visited neighbors, then we'll look at this one. It's non-visited neighbors, then we'll look at that one. And one at some point will be done. This will be visited, and this will be no more visited. And yeah, when we look at the neighbors, so I mean, so far it seems to be pretty, yeah, just DFS with, then we will need to do DFS again. And instead of tracking the visited, we'll just flip them. But yeah, and it would be nice to do that right from the get-go, but we can't do that until we know, until we did the first check. And by the way, one optimization that stands out, because we will have this list of visited, we might just use that to flip them if we know, yeah, if it's a the region is surrounded, yeah, we can capture it. So we'll know that all this. So we don't have to do the DFS twice. Yeah, we'll have it in the memory already. So that's kind of the plan. Yeah. Loop over the matrix, DFS, and each O each DFS over each region, then track visited if region surrounded. How do I spell surrounded? Flip, capture, visited. Is there any other optimization likely that immediately stands out? I mean, what if we just looked? Because another way to do it is to, okay, let's go over, by the way, we don't need to check those on the edge. Okay, so now excluding edges, what they call it, border, or the outer edges, yeah. those outer edges, yeah, we don't need to check them, but those internal should be checked. And is there another optimization? Because I mean, if we do go over the outer edges, there is up to 200. The size is up to 200 by 200. If we check the outer edges, I mean, another logical solution is to check the outer edges, and those we know will be linked to non-surrounded. So we don't need, we can sort of mark them as but it's something not to capture, and so that means everything else should be, yeah, that's another way, yeah, kind of to exclude the non-surrounded parts. But I mean, that we'll need to use some memory to remember all those that are not surrounded. So it just we'll still need to do traversal.
What about downstairs?
So I don't think that makes much sense. Okay, let's try to code this within, I don't know, next 15 minutes. So the DFS will be working with that region. And I'm thinking, should I do a nested function, or should I do should we do a separate function, which will be DFS? Because I mean, we'll need to, if we do it as a separate function, we'll need to pass the board. Yeah, because what we need from DFS is the knowledge. Okay, is it surrounded? And the visited, yeah. And it's kind of, to the DFS, we need to pass the position, just to, well, it's kind of row and column integer. And we need to return two things. We need to return a bool, and we need to return visited, which is a slice of slices of integers. I don't remember, do I need to put these in parentheses? don't remember. We'll check it. So yeah, we'll need, or if we do it nested, then we'll just have access to all these. I mean, it will be in the scope of this function. Okay, but let's start simple. So we'll go over column, row. Yeah, for row we'll start 1 row, and by the way, yeah, we just can say rows. Calls rows is board, length of board, and yeah, the first row. So rows, we need to go until the end of rows, but -1, we don't need to check. I mean, it doesn't really row plus plus, but it just doesn't, yeah, it doesn't make sense to check this. So that row and the last row, we don't need to check as well, right? Right. Yep. So for column, now we're going to be columns. Same thing, starts with the first one. Less than calls -1. Now, so this position, if board row column, if it has an O, so that means we need to, yeah, we found some region that we need to see if we can capture. So we'll need to do DFS. We'll need to do DFS on it. But DFS will return us these values. Return these two values. So it will return is surrounded, and it will return visited. Okay. If we want to deal with these right here, so it will return these, but we need to pass the row, column, and board. Right? Yeah. Now, if is surrounded, then we need to do another. Will have visited. Yeah, we need to flip all the visited then. Then we'll say, okay, then capture, and capture will pass the board, and we'll pass the visited, and those are slices of Oh, by the way, wait a second. Yeah, that's a slice of byte. And visited is a slice of integers. Yeah, so it's different. Those are just byte, and visited is a slice of integers. And yep. And then we'll have a function to do that. So function capture will take board, take visited. Yeah, so it will take these things. By the way, we don't need to specify them here, but so capture will just, the reason we can, we're passing the slices, which are the pointers to the underlying arrays, so that's why we're passing by pointer, essentially. Pointers. Well, that should be it. I mean, we just need to implement these, and that should be the solution. So capture, all it needs to do is to go over the visited, or is range visited, and visited will have these pairs of values. Will be v0, so there will be a column, and it will be, and so on the board, if I could spell board, on the board, we need to say that this is now x. It's pretty much all. We could just put this function here, basically. Just 3 lines. I just wanted to. I just wanted to stop this depth of indentation. And abstract away that thing. Because if surrounded, just do the capture. Although it's pretty much just one loop like that, because we have a position already. Anyways, so DFS is the magical one. Is it really that magical? So we have some kind of position, in the matrix. That's our current position. Now, so now, yeah, if, and we will only, yeah, what's the base case? Well, if there is no more, by the way, here's the thing, the visited needs to be, we need access to the visited at each call. The visited needs to be passed along. There's a slice of these positions, list of these positions. But here is the trick. Here is the trick. We need constant time check, not linear time check of visited. So that means visited should be a map. Or, no, it could be a matrix. Yeah. It could be a matrix as well. Yeah, so we need to then that will look a little bit different. Yeah, could we use the matrix that we have for that? Like mark those nodes as visited. I think they're like gray, white, gray, black. If we try to, we cannot change them because otherwise we will need to, because we need to have it back. And no, that's why we need some extra memory. Some memory on a matrix, yeah. And that visited matrix need to be either passed here not only returned, but also, yeah, so we can't use it. You can't use just a list of positions. No, we need a matrix. Visited needs to be a matrix. Okay. So if we do find a no, we need to create yeah. So yeah, so visited will be we'll have some pointer to that visited. We'll update it and return the slice. Yeah. capture, we'll also need to do so capture, we'll need to go over the positions of visited. And update the board. And it's pretty much like that because, I mean, so we'll see visited. Well, we will have this. Now, in this case, it is going to be a bit different row. It's going to be a row column, but only if actually, now what? Yeah. So for each, I'm thinking about time complexity here because if we have to go over the visited, which is gonna be kind of the full matrix, and for each region that we find, and there could be how many regions? There could be the number of regions, I mean, could grow. It's sort of n. There could be n. Well, every other could be a region, and for each of those, we will go over the entire board again. Not just the region itself, but the entire board to check which one is the visited with, so which one is to capture. So I think it makes sense to return the visited as a slice, or collect those as both the matrix for quick reference, but then we need to go, when we go over all of the visited, we want to have it saved in a slice. So to capture, yeah. If we were to capture, yeah. Or there is another, and I guess the map would be the answer here then. Because a map of arrays. Yeah, visited needs to be a map of arrays. If we return that, because yeah, you can both iterate over them. You can, yeah. Yeah, that's a better. So yeah, because we can also iterate over them, and we can yeah, check visited. Pretty much constant time. So then we don't need to do it like that. We could be back to our basic. Yeah, we'll be iterating over the visitor will be a map. Will be a map of integer arrays. The map will have these integer arrays, and yeah, so we'll be checking those. Pretty much we just need a set. Need a set. Yeah, so we'll go over these and we will know that all of them are visited. And we don't need, we actually don't, we just need the keys. Yeah. Because that will be like, be the position. Now back to the question. Okay, how can we pass that map? We have the board, we have the visited as this map of, and pass it, and we will return it. And we will be returning it. On each call. Right? Right. So well, that means if we want to call DFS, first need to say make. Well, let's initialize visited is a map. We don't know the length of it yet. We just know the type is this. This is what we want to make. Do we? And then in the DFS we'll mark it as visited. Yeah. Yeah. So hash map looks more promising here. It's a pointer type. Okay, so we have the board, we have our visited, and we need to look at this current position. First thing we do in this call, we say that in our visited, we need to create that this position is an array with R and C. Row and column. And we'll say that visited pause is true now. Good? Yeah, that's good. So that's first thing we do. Now we need to go over this current positions. Oh, it's around its adjacent. So neighbors around, yeah, check its neighbors. The neighbors of, yeah, and we know that the neighbors are, there is only 4 neighbors, okay, so what we need to do is, and by the way, if we find any neighbor that's on the edge, then we can return pretty much immediately. Yeah. Yeah. We don't need to go over all the others. I want to see if we can have a quick exit. If one of them is on the edge, so this if something, if will be, if it's on the edge, then the region cannot be captured, and our DFS should stop. And our DFS should stop. That could be our base case. So we should probably return. But not only should we, so there should be a flag then. There should be a flag that that is surrounded. By the way, it's typically is surrounded, because that's the first thing we care about. Yeah. Each node will be returning surrounded value. And we can, yeah. Mhm. Is surrounded is false. Then each neighbor will return that also. And if not is surrounded, then we need to do return false and visited as it is. Mhm. But that check needs to be done at each neighbor. So for each neighbor, we'll run DFS. Say surrounded, visited. We'll say DFS, and we'll pass the row. So we pretty much need to do the same thing with one difference. And that is so we'll need to do that 4 times, but each one the first one will be, let's go clockwise, so it will be just the row up, row -1. So the column go down, this one, column -1. And we know those exist, right? Wrong. We need to call them only if they exist. But they might be on the edge. So when do we check that this position is on the edge or outside? And we, by the way, need not check outside. We don't need to do the DFS yet. We need to just do this initial check. Before we call DFS for this node, we need to say, before we call DFS, we need to make sure that row, not 0. And column is not 0. And row is not rows. It's 1. And column is not it's 1. So this same check that it's not on the edge. If it's not on the edge, then we will call the DFS for it, yeah. And at some point else, that is not then return. Yeah, then return. So then it's something like that. And we can do that. We could do that at the entrance, yeah. So we'll point this. Yeah, we could just say, okay, that's the visited. Just make it a bit shorter. That's our visited. Do we need to return the visited? We don't care about the visited actually. If it's not surrounded. But we need to, visited will be something with this current value. Yeah, we don't need to put in there. So if basically it's like that. If 0 or 0 or row. Yeah, so if it's on the edge, we're living on the edge. We return false. We're living on the edge. And by the way, we don't need to. So in this function, we will call them, okay? But we will stop if it's on the edge. Now, if one of these, if any of these return, that we don't need to continue. So basically that could look like that. Or, I mean, what is more readable? Put it in the in this initialization statement like that. Or what is more readable. Yeah, here we have the row 1, the row down, column up, column down. Or, yeah, well, let's try it like that. Let's see if we can. So, yeah, we went over those. And we have if none of them returned, that means we need to return true. So yeah, return visited, yeah. Because, I mean, each call of DFS is going to return this, but it doesn't need to get it. So surrounded is false. But then we updated. And by the way, we don't really need the surrounded. Do we? Do we? Surrounded. I'm always confused when I see like multiple assignment. And one of the values has been initialized before, and the other one is just being initialized. Like, I don't know what would happen if we don't have it initialized here. And we'll obviously need that to initialize it here. But the visited will be, the visited is a map. Okay, this will be passed and that will return a visited. So we'll reinitial visit. We'll reinitialize the visited here. But surrounded is only known here. So each of these calls needs to be a new one. If we don't have this surrounded. Pretty much. Yeah, it needs to be like that. So it's not surrounded. Yeah. Okay, so basically, this should be something about it. Should this work? We're living on the edge. So we're out of the first hour. Just implementing the logic. Implementing, I mean, the code. Implementing the code. Let's try to run it because yeah, we definitely have some extra here. Yeah. Extra. I think we need parentheses here. Paren. That's the problem. keywords is not defined here, so we need to. Okay, well, at least it ran. And so it looks like it didn't, it hasn't captured anything. But I mean, is surrounded. So if none of them triggered false, so they were all surrounded. Oh, by the way. So when we come in, we check all the neighbors. If the neighbor is we need to check if it's, by the way, we only care about neighbors that are that are 0. So we should return if it's on the edge, should return false. If it's an X, we should return true. It is surrounded, at least on that side. So there is another case. We need to get out of it, not go anywhere. So yeah, if board at these positions is an X, return true. Visit it as it is. Memory limit exceeded. If and that needs to happen to be checked for H. Yeah, the first thing we need to check. If we go, and if it's an X, we need to return. Not doing anything else. If it's not an X, then it means it's a no. Check if it's on the edge. Now, if now we go from this one to the top, and it returns. So it does make a call. Surrounded is returned, visitor is returned. But it actually, yeah, it just does that. It's like it's an X. Yeah, so it returns true. This upper returns true. Yeah, so we're good. So we're not triggered on the right. It has a null. So it not on the edge. So it checks its neighbors. One of them is this. Oh, this one returns true, true. This one returns is called returns all the truths. Now we also need to check it's been visited. So we don't want to go. Yeah. If it's been visited, we don't need to call it. Or we can just return true. So if X if visited, and we will pass int RC. So if that or that, it's been visited, yeah, because otherwise, yeah, we just go in circles. Oh, we need to do that. So if that position is already visited, finally. Jeez. Finally, yeah. So 1 hour 16 minutes we solved this problem. Could mark itself a bit out of time. Yeah, so that suggests practice. Practice to do it on time. But yeah. Nice. Okay, so this is the solution works. It's and what I like about it is so it's based on several things. It's based on DFS, and the type of traversal here. We also needed a hash map, the type of the data structure to store visited and track the visited. In terms of memory, so in terms of time, in terms of memory, we are, so some used half of the memory of some solutions, but it's still 6 megabyte, but many were 12. Okay, well, basically that's the solution of this problem live. We are about 40 minutes, 35 minutes over, 40 minutes overtime, I guess, into overtime for a problem like that. It could, I'm not sure if it's gonna be like a warm-up type of problem. It depends. The challenge here was just the implementation. The overall logic we figured out that needed a type of traversal, that needed type of data structures. Yeah. And so good practice. medium level problem solved. Thank you for watching, and we'll see you in the next video.